Many companies have benefited from practicing and enforcing some types of coding standards. Coding standards are there to ensure we have quality of the code. Coding standards could be standards in how we name various, elements and variables, whether or not certain practices are permitted in the way the code is actually structured, as well as the things such as even the form and flow of the code as well. The idea behind this is we can prevent, two things: bugs and flaws. A bug is usually a coding mistake, where a flaw tends to be more of a logic error or a problem in the actual coding process. We want to prevent these. We want to prevent any type of errors through adherence to standards that are reflective of what are good practices in the business today. The thing is, there are many known vulnerabilities, and we should make sure that we have tested to make sure we don't have those vulnerabilities. It could well be that by not following standards, I've introduced vulnerabilities that I don't know about. It's important that I test, that I know whether or not I have any of these problems. In fact, it's not acceptable for my system to have vulnerabilities today that I should have known about. And we turn around and say, well, I didn't know about that vulnerability. Well, I should have. The whole purpose of following standards is so I don't continue to repeat the mistakes that have been made in previous years. This is where tools such as OWASP can be handy. OWASP, the Open Web Application Security Project, lists for us the top 10 most critical vulnerabilities, most common vulnerabilities in web applications. It also has a list now of the most common vulnerabilities in mobile applications. This can be an invaluable tool for a developer. A developer should take a look at this list and see, have I checked whether or not I have any of these vulnerabilities in my code? One of the things to remember is that many of the breaches we have are not because the developer made a mistake. Their breach is because that is a weakness in the actual nature of the language or nature of the code. And if the developer has not taken steps to eliminate those problems, then those problems will almost undoubtedly be there. OWASP can highlight for us what are the known vulnerabilities, so I can check to make sure I don't have any of them. The other thing is we want to avoid poor coding techniques. We used to call this like spaghetti code, where my code went all over the place, calling different modules, different parts in different places without any logical flow. This made it very difficult to troubleshoot and could easily lead to maybe a branch that didn't resolve correctly, an error that was not handled. We want to avoid poor coding techniques in the way we actually then write the basic code itself. These can be, for example, vulnerable commands. We may have rules about whether or not in COBOL we would have allowed a go to. We, of course, will look at rules, whether or not we allow a post, a get. What are the rules we're going to put in place that will help us to ensure that we have not used, suspect behaviors that could easily be compromised by an attacker? In order to build a system that is resilient, we need to know our enemies. We need to understand what are the threats that my system will face. This is where we often fall down, because we're very good at trying to understand what the business needs and the business function. We also look at what are the normal errors that a user could have and how do I prevent those errors. But I also have to think from the perspective of the misuse. In other words, not a user that makes a mistake, but rather a person who intentionally tries to abuse or damage the system. And this is where we need to learn more the art of threat modeling. Threat modeling puts ourselves in the position of an adversary. who's looking at our system from the perspective of how could I misuse this case? How could I misuse this system? So we anticipate normal use as well as normal errors, but also in threat modeling now, we anticipate misuse and intentional errors that could be then forced upon the application. We've put ourselves in the position of the hacker, well, the black hats. We identify who some of the misactors could be. Could they be internal? Could they be external? Are these, of course, misactors then thieves or people just trying to get attention? We need to understand who then the threat rests with, because we can more effectively defend ourselves if we know who then the threat agent is. And as a result of this, we design code resilience. We make our systems resilient to any type of a possible threat. By anticipating what a hacker would do, I can then put in defenses to make sure the hacker would not be successful. One thing we have to excel at is error handling. If a program hits an error, we have to make sure that error has been resolved correctly. And that is, does it error out? Does it go to some error code? But the one thing to be sure of is that a hacker cannot disable or bypass the security of a system by introducing some type of an error that could cause the system to handle that operation incorrectly.